Alright, so in this video, I'm going to explain how to find the frequency of a note's pitch given this equation. And for those of you that aren't musicians, pitch is, well, simply put, it's the sound. It's the sound, the note that comes out of the instrument. And it's all based around the tuning note used mainly in orchestras, A440. And A440 is the A above middle C. And I did something real quick here in bass clef, because I'm too lazy to draw a treble clef, and I play a trombone. Right here is middle C, right here on this first ledger line. And up here is A440. And what A440 is the note A that has a frequency of 440 hertz. So, in order to find any note's frequency, we use this equation, which is P of n is equal to 440 times 2 raised to the power of n over 12. And alternatively, you can write this as 440 times the 12th root of 2 to the n. And what all this means is basically you take the 12th root of 2 and then raise the result to the nth power. Or you can even say raise 2 to the nth power and then take the 12th root of that. So, and this is saying that n is the number of half steps above A440 or semitones above A440, and P of n is the frequency of that note in hertz. So let's do a few examples. So let me erase some of this stuff, and I will give you an example. So this is assuming we want a notes, a frequency of a note, given how far away it is from A440. So, let's say I want to find the frequency of, I don't know, B flat. I want the frequency of the B flat above A440. I'm not going to draw it again, but I want the next note up. And of course, for all you musicians, this is also the same as A sharp, but I like saying B flat better because I tune my horn to that. And again, for those of you that are musicians, I'm speaking in terms of concert pitch. So if you play trumpet or clarinet, this would be B, this would be B, this would be B. And for those of you on alto sax or French horn, I'm not going to tell you anything else. So the next note up is, this is the next note up from A440. So that will be n equals 1. So we just plug this into our little equation. So P of 1 would be 440 times 2 raised to the 1/12. And this is basically saying 440 times the 12th root of 2. And let me get my calculator out. Just get an approximation. Just put new batteries in this thing. Alright. So if we can get that into the display. So I want 440 times 2 raised to the 1/12 power. And I just returned what I wanted, so I should have pressed the approximately equal to sign. So it gives me 446.16. I'll just say 16. Oh, it's 466. I'm sorry. So the frequency of B flat above A440 is 466.16 hertz. So that's B flat. Now let's do another one. Let's just do one more. So, actually let's do two more. Another example would be to find the frequency of the next A. The A above A440. Well, this A is 1 octave higher, and there are 12 half steps in 1 octave, so N is 12. So N is 12, and this would be 440 times 2 to the 12 over 12, which is the same thing as 440 times 2, or 880 hertz. So, basically, simply put, this is saying that if you take a note and then take the note an octave above, that note will have a frequency double that of the note in one octave below. So let's do one more, and this time I want a note below A440. So here's another one. I want the frequency of middle C. And now, middle C is a fundamental note. It's something that musicians should usually hear, kind of tune to. And it's the reference point for our A440. It's also designated in scientific pitch notation C4. Not the explosive, but the note C4. So, we first have to find out how many semitones or half steps below A440 this is. So, I'm going to count. So, we have A, and then A flat, that's 1. G makes 2. G flat, that's a G flat. G flat, F, E, E flat, D, D flat, and C. So let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9 semitones. So N would be 9. N would be negative 9 because you are 9 semitones below A440. Okay, so we just put negative 9 into our equation. And this becomes 440 times 2 to the minus 9/12. We can simplify that fraction. That becomes to the minus 3/4. 440 times 2 to the minus 3/4. Which is the same thing as saying 440 over the 4th root of 2 cubed, which is 440 over the 4th root of 8. So let me use my calculator again. Don't know if you can all see that. Okay, so I want 440 times 2 to the minus 9/12. So, whoops, I should put some parentheses there. To the minus 9/12. It approximately equals to, I have 261.626 hertz, which is exactly what agrees according to the middle C article on Wikipedia. So that's 261.626 hertz. And that's all there is to finding a note's pitch.